Low voltage refers to an electrical current with a voltage below 50 volts. It's often used for safety reasons or in low-power electronic devices. The applications for low voltage are quite diverse. Firstly, in landscape lighting, low-voltage systems are commonly used to power outdoor lighting fixtures. This is because low voltage reduces the risk of electric shock compared to standard household voltage. Secondly, doorbells often utilize low voltage for safety. A transformer steps down the standard voltage to a safer level for the doorbell circuit. Thirdly, some types of electronic devices such as certain sensors or control circuits operate on low voltage for efficiency and safety. Fourthly, in model trains and other hobby applications, low voltage is employed for controlling the speed and direction of the trains or powering other accessories. Fifthly, certain types of thermostats utilize low voltage for control circuits to operate heating and cooling systems. Now let's move on to the subpanel. A subpanel is an electrical panel that is connected to a main panel. It distributes electricity to a smaller area, such as a section of a house or a specific appliance. Here is more detail about subpanels. The purpose of a subpanel is to extend the capacity of an electrical system. When the main electrical panel has insufficient space for additional circuit breakers, a subpanel can be installed to provide more capacity. Subpanels enable the separation of circuits. They allow for the isolation of circuits, making it easier to manage and troubleshoot electrical problems. Subpanels simplify circuit management. They group circuits serving a specific area or appliance, simplifying maintenance and reducing the need to run long circuits from the main panel. Subpanels are commonly used in several scenarios. Firstly, in home additions or renovations, subpanels are often installed to accommodate new electrical loads. Secondly, in workshops or garages, subpanels can provide dedicated circuits for power tools and equipment. Thirdly, for outbuildings like sheds or detached garages, subpanels supply electricity separately from the main house. Fourthly, with electric vehicle charging, a subpanel can handle the high current demands of an electric vehicle charger. Fifthly, for critical loads like backup generators, a subpanel can isolate essential circuits from the main grid during power outages. Subpanels are connected to the main panel via a feeder circuit, which consists of circuit breakers and appropriately sized wires to handle the load. The subpanel has its own set of circuit breakers to protect individual circuits within the area it serves. The ground wire is a conductor that provides a path for electrical current to flow safely to the ground in the event of a fault or equipment malfunction. It's typically green or bare copper and connects to the grounding terminals of electrical outlets and equipment. Let's examine the function and importance of the ground wire. Firstly, the ground wire provides a low resistance path for fault current. In the event of a short circuit or equipment malfunction, the ground wire allows the current to flow back to the electrical source, tripping the circuit breaker or blowing a fuse to de-energize the circuit. Secondly, the ground wire protects against electrical shock. By providing a path for fault current, the ground wire helps prevent dangerous voltage from building up on the metal parts of appliances and equipment, reducing the risk of electric shock. Thirdly, the ground wire ensures proper operation of overcurrent protection devices. Grounding allows circuit breakers and fuses to quickly detect and interrupt fault currents, preventing overheating and potential fires. Fourthly, the ground wire stabilizes voltage. It helps maintain a stable voltage level throughout the electrical system, preventing voltage fluctuations that can damage sensitive electronic equipment. Fifthly, the ground wire reduces electromagnetic interference. Grounding helps minimize electromagnetic interference, which can disrupt the operation of electronic devices and cause data loss. Ground wires are typically connected to a grounding electrode system, such as a ground rod or metal water pipe, which provides a direct connection to the earth. The size of the ground wire is determined by the size of the circuit conductors. The National Electrical Code, or NEC, specifies the minimum size of ground wires based on the amperage rating of the circuit. According to NEC Table 250.122, for example, a 15 amp circuit requires a minimum 14 American wire gauge copper ground wire. A 20 amp circuit requires a minimum 12 American wire gauge copper ground wire. A 30 amp circuit requires a minimum 10 American wire gauge copper ground wire. A 40 amp circuit requires a minimum 10 American wire gauge copper ground wire. A 50 amp circuit requires a minimum 10 American wire gauge copper ground wire. A 60 amp circuit requires a minimum 10 American wire gauge copper ground wire. Ground wires are typically green or bare copper, making them easily identifiable. They should be securely connected to the grounding terminals of electrical outlets, equipment, and panels. It's important to never cut or remove ground wires, as they are essential for electrical safety.